Right, welcome back. We're going to continue on looking at examples. So let's look at this one. We're going to increase our speed a little bit faster. If any of the points or any of the rules used make you uncomfortable, you're not comfortable with them, then you can feel free to contact me and then we can resolve it. Okay. So we have our premise P implies R and Q implies R. That's a premise. We've got a conjunction. It's easy. We can split these two. Number two, we can have P implies and R. Sorry. You can have P implies R, and that will be elimination on the first one on number one. Then number three, we have Q implies R, conjunction elimination on the second one on number one. All right. So now we are trying to prove P implies Q, or P and Q implies R. The way to do it is as follows. Any time that you have to prove an implication, right? What do? Implication introduction works in such a way that you assume the left-hand side of the implication, then you prove the right-hand side. Then you can, if you manage to do that, then the left-hand side implies the right-hand side. So assume P and Q. So number 4, I'm going to assume P and Q. This is an assumption. Then number 5, after I've got P and Q, then I can now start with my assumptions and so forth. So I want to prove R. So if I want to prove R, I can then, for example, open another subproof internal there which says not R. Okay, so not R is an assumption. And then if not R is true, what's going to happen? I've got not R, I can have not Q here. Okay, I can have not Q, right? Then I also have not R, that's modus tollens. I don't know if you remember. Modus tollens, number 3 and number 5. Then number 7, I can also have not P, right? That is modus tollens on number 2 and number 5. So once I have not P, I have P and Q. Then over here, I'll have a contradiction, negation, elimination. Or before I get to the contradiction, I need to have P first. P, which should be conjunction, elimination, position 1 on number 4. Then over here, I have a contradiction. That's negation, elimination on number 7 and number 8. 7 and number 8. Therefore, from here, I can prove by contradiction that R is true, proof by contradiction. That is from number 5 to number 9. And then I can close this one off. I've assumed P and Q. Then I have also assumed, after that assumption, I will have, I've proved R. Therefore, the left-hand side is equal to the right-hand side. I've assumed the left, proved the right. Number 11, P and Q implies R becomes true. And this is implication introduction on number 4 to number 10. Like that. Right. Let's look at another one. So you can prove, because you have implication, we said implication can be used to create from nothing. Okay. So if we have nothing, and the only time you can do it is if you're proving an implication. Why? Because you can assume the left and prove the right. So you can start your number one. You don't have any premise here. So your number one will be assuming the left, which is not P or Q assumption. Number two. Now you want to prove another implication, right? So the right way to go about it is to assume the left of that. And you see now there's a subproof inside a subproof. So this subproof should close with proving a Q. And then after closing this subproof, you are going to conclude that P implies Q is true. And then you close this subproof, and then you have got not P or Q implies P implies Q, like that. So let's see how that proceeds from here. We have got P. So we have got P and we've got not P or Q. So we can start by saying not P, assuming we want to use O elimination. So we start by this side, then we go on to the other side. An assumption over here. And then not P, I have got P over here, which will reach a contradiction. That's negation elimination on number 2 and number 3. Then this, after this, number 4, I can use another rule. So 1, 2, 3, 4, number 5. The number 5, I can use the rule. If I have a contradiction, I can prove anything, okay? If I have a contradiction, anything can be true. So I can come and conclude that Q is true. That's contradiction elimination on number 4. Then we've proven Q here. Then next, number 6, we open the other subproof to start from the right. We've got Q. That's an assumption. All right, we want to prove Q. So this is easy. We simply copy Q here. That becomes our conclusion. We're copying number 6. So not P is given as Q. Q is given as Q. Therefore, Q is true. And then this is number 8. And this is disjunction elimination on number 1. That's where our disjunction was. First one was 3 to 5. Second one was 6 to 7. Now, after doing that, we can then conclude number 9 that P implies Q is true. P implies Q is true. Then we close our main subproof. Then we come to our conclusion. We're saying not P or Q implies P implies Q. Like that. And this is implication introduction from number 1 to number 9. The only time you're allowed to do this, start with no premise if you are proving a implication. Then another one, we're going to have P implies Q. This particular case. And I want you to observe something. P implies not Q is a premise. Number 2, we want to prove this. Right. So we want to prove Q and not P, and we want to prove P and not Q. It's an O. So for us to prove an O introduction, if you have to do an O introduction, you just have to prove one side, either this side or that side. So we have got P implies not Q. So the way to go, we can start with P or not P. P or not P. This would be the right way to go. Then we are going to have LEM. Then number 3, we can then say with disjunction, we now need to do disjunction elimination. We've got P. And then P is an assumption. Then number 4, I've got P implies not Q. I have not Q. This is implication elimination on number 1 and number 3. I've got P and not Q. Number 5, I'll have P and not Q. All right. That is what we have now. That is what we have. So then we P and not Q, that's conjunction introduction on number 3 and number 4. So number 6, I've got P and not Q. So or introduction or disjunction introduction says as long as one is true, X or Y, as long as Y is true, then Y or anything becomes true. As long as X is true, X or anything is true. P and not Q is true, then this or anything becomes true. So P and, Q and not P, or P and not Q is true. And this is disjunction introduction on position 2 on number 5. Right, we can close this. We need to get to the same conclusion, and that's number 7, from not P. Right, by assuming not P, right, we then come with a deficit. There is no way to proceed from here. Right. The possible way would then be to assume Q or not Q, because not P alone does not give us any new information. We cannot use this P because they are on the same level, right? This subproof is not nested in the subproof, so this P is not part of that, right? Don't make that mistake. So this is an example of a question that came in the exam but did not have a solution, right? So the way to quickly check that is to draw a truth table for it. We would like to then draw a truth table for it. So if we take this and then we want to draw a truth table for it, we can see it's only P and Q, so it's going to be short. We have got 1, 2, PQ, true, false, true, true. True, true, false, false. Then we've got not P, but not Q. Not P will be false, false, true, true. This will be false, true, false, true. Cool. Now we want P implies not Q. So P implies not Q. True implies false, that's false. True implies true, that's true. False implies anything, that's true. False implies anything, that's true. Then over here, we want to build this one up now. So we'll start by having Q and not P. Q and not P, true and false is false. False and false is false. True and true is true. False and true is false. Then over here, we have P and not Q. And then P and not Q is true and false is false. True and true is true, false and true is false, false and anything is false. Then we have a disjunction, so we're going to have now Q and not P, or P and not Q. Right. So we're looking at this, the disjunction of this will be false, this will be true, this will be true, this will be false. So now we go row by row, premise, conclusion. False, we're not interested. True, 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 false. By virtue of this, we have got not valid. So arguments that are not valid do not have a path, a deduction path from premise to the conclusion. You cannot use natural deduction rules on them. So we make a realization. It's not every question that we are going to find a pathway for it or where the rules will apply. In this case, it didn't. And I've gone on further to prove that it is impossible to get a pathway because it is not valid. Unfortunately, for the participant of this exam, it then becomes a case of one might spend more time than necessary doing this question while it leads to no answer. So the most common question that I receive here is to then say, well, how do you see if a question does not have an answer? So I would like to be one of the mindset to say that this was a mistake. It was not supposed to be that case. But we have seen scenarios where the other question that asks you to use a truth table actually has a valid one. And we've seen one where they gave you a sequence that is not valid and asked you to use natural deduction rules. So it can happen. How it can then be resolved at this point, I do not have a solution. But once you practice enough, you can start picking up these things. Say, I don't think this one is going to go anywhere. All right. Let's meet in the next video.